Hello everyone and welcome to ACAD-08, where we will discuss the methods by which a ground controller can expeditiously direct the flow of traffic. So we are finally getting into the movement of aircraft. So what is ground movement controlling? Well, the ground movement controller, or GMC, is responsible for the aircraft movements on the ground, as the name implies. So this will include aircraft that are on taxiways and inactive runways. However, the air controller, also known as tower, will control all of the active runways. The GMC positions will typically use the radio call sign ground, since they are controlling ground movements. These taxiways and inactive runways or taxiways and runways even, more generally, are often known as movement areas. However, GMC is not responsible for aircraft movements within what we term non-movement areas, for example aprons, but they may provide advice within these. If no ground movement planner, which we discussed in the last ACAD, is online, the GMC will absorb its responsibility. And this works all the way up the chain. This concept is known as top-down controlling. So let's have a look at an example of a non-movement area. In this case we have the general aviation apron at Liverpool John Lennon Airport. In this case it is marked by using a grey colour. An aircraft will quite often only contact ground once they are holding short at kilo here, and then request further taxi instructions. So what actually is an apron? Well, an apron is the area of an aerodrome where the aircraft are parked. This is then typically used for loading and unloading aircraft, for fueling, and quite often for any sort of maintenance. Movement within an apron is largely up to the pilot, but entry and exit into them should normally be approved by a controller, which will be the ground movement controller, or another controller which has absorbed its responsibility. Another example of a movement area could be end of runway or EOR parking slots, where aircraft perform their final departure checks. And this is quite often done during larger events. So in this case we have the EOR parking at Nellis Air Force Base, which we have used as, or designated as, a non-movement area to aid in the control at red flags. So let's have a look at the aerodrome information and ATIS information. So when an aircraft asks us for the aerodrome information, we want to give them the runway in use, the direction of the traffic circuit, the current surface wind, and the QFE or QNH. So in this case, Hornet 1, in this example even, Hornet 1 has requested the aerodrome information from us, and we will respond as follows. Hornet 1 Anapa ground, runway 04, left hand, surface wind 090 degrees, 5 knots, QNH 2990. You'll notice how when I give the QNH, you don't voice the decimal in it. And when you are giving the surface winds, you give it as the number of degrees and then the word degrees, and then the number of knots and the word knots. Then all the information that is required to be read back is read back by the pilot. So in this case, this will be the active runway, the circuit direction, and the pressure settings, so either QFE or QNH. So the ATIS, or Automated Terminal Information Service, will include much more information, and this also takes some of the workload off of the controllers at busy airports. The ATIS is updated every half an hour, and each new version is designated with another letter of the phonetic alphabet going up in sequence. So if an if an aircraft reports having the latest information, this could be information PAPA, you only need to confirm the aircraft has the correct QNH or QFE, as this setting is so important. Now, let's have a look at taxi instructions. So taxi instructions have two main parts. They have the clearance limit, which is simply how far an aircraft has been instructed to go, and the route they need to take to get there. And these instructions are all read back by the pilot. And then if the QNH or QFE has not yet been confirmed by you, you would want to confirm that in the taxi clearance. So an example taxi clearance in this case could be Hornet 1 taxi holding point Delta 1 runway 04 via taxiway November QNH 2990. So in this case we are clearing the aircraft, or instructing the aircraft even, to taxi to holding point Delta 1, which will be a marked holding point on their charts. And this is for runway 04. And they are being instructed to taxi via November. If there are more taxiways in this sequence, you simply extend the sequence. When we are thinking about creating a departure sequence, there are a few things we want to think about to make it as efficient as possible. Firstly, we have any required wake turbulence separation, which we will not cover in great detail currently. Then we have any route separation, which is where aircraft that are flying on the same route will require more separation to ensure they don't hit each other if they go at slightly different speeds. So if we have two aircraft that are going north and one aircraft going south, we typically want to put the aircraft that is going south in between the two going north, which will maximize efficiency based on this route separation. We also want to think about the aircraft's missions, if we've been given them, or any slot or departure times. And the fact that tactical command and control might want certain flights first, or in a certain order, or at a certain time. And we then need to kind of do our best to accommodate for that. The other important thing to mention is this red carpet rule. Once an aircraft has been instructed to follow a certain route, aircraft can follow it, or they can give way to it, but they should not be instructed to cut in front of it. And it is called this red carpet rule because once you clear an aircraft, you can imagine a red carpet is rolled out along their route, and it is then kind of picked up behind them and no one else can enter it. To achieve this, we also have what we call partial taxi clearances. So this can be used for, as we say, ensuring the red carpet rule. It can be used for confirming departure sequencing or to create a departure sequence. And it can also be used if certain emergencies have occurred or things like that. So in this example, we are telling Hornet 1. So Hornet 1, taxi straight ahead on November, hold short of taxiway Alpha, QNH 2990. So we are just instructing them to literally taxi straight ahead onto November and then hold short of taxiway Alpha. We can also give what we call conditional taxi clearances or conditional taxi instructions. And these place a condition on the instruction that is given to the pilot. So for example, after the Viper passes left to right and then normal taxi instructions or giving the instructions and then follow the aircraft, so on and so forth, or give way to such and such an aircraft. More can be seen in DCP 102. However, conditional taxi instructions should not be used when there are multiple flights on the taxiway or any confusion at all could exist, for obvious reasons. So an example of this could sound something like Hornet 1 after the Viper passes left to right on November, taxi holding point Bravo 4 runway 22 via November Bravo, the QNH 2990. And this is then sufficiently read back by the pilot, including the condition. Then we have the transfer to tower. So verbal coordination typically isn't required between air and GMC. However, aircraft should be transferred to the air controller once they are nearing the holding point for an active runway and no ground conflicts exist. That part is important. So let's have a look at an example of this.
ACAD-08 ground, Scorpion 11, single Viper on the hotel dispersals, request taxi to remain.
Scorpion 11, your VFR to remain is approved, squawk 7010, then taxi holding point runway 28 via Yankee.
VFR to remain is approved, squawk 7010, taxi holding point Yankee runway 28, Scorpion 11.
Scorpion 11, contact tower now, frequency 339.85, bye-bye.
Tower 339.85, Scorpion 11.
Now let's have a look at handing a frequency over to another controller. So when a frequency changes between controllers, we provide the oncoming controller with the following information. Firstly, any information that has changed since the initial controller brief, either at the start of the shift or typically for DCS purposes at the start of the mission. Then we have current instructions that are provided to aircraft. We also want to give the oncoming controller what unanswered requests have been requested by aircraft. We also want any aircraft that are operating on non-normal or emergency procedures. And then in public servers especially, it's always a good idea to indicate any NORDO, which means the aircraft is operating without a radio, or no TR, which we call an aircraft which is not able to transmit but can receive aircraft within the controller's area of responsibility. And in this case, an example handover message could be: oncoming ANAPA GMC, Hornet 1 is taxiing Bravo 4, no other remarks, any questions? The oncoming controller replies, and then we have a your frequency, my frequency, explicit handover of the communications between the controllers. If we are using flight strips to manage aircraft, we quite often use strips for larger events where it is less applicable for us to just kind of remember everything. So we can move strips between different sections, as is shown in this wonderful GIF. And we can also send strips to other controllers and edit information. There will be a dedicated video on the use of this piece of software. Some useful tips for larger events. Preparation is key. So we want to get the expected list of flights and any flight plans ahead of time, and ideally use this to create our electronic strips. Then we want to write down the information or get weather information ahead of time so that we are prepared for it. And we also want to coordinate with the tower controller to get the expected departure runway and potentially arrival runways or any other relevant information. So to summarize ACAD-08, we have looked at GMC's responsibility involving movement and non-movement areas. We briefly looked at active versus inactive runways. And then we had a look at taxi instructions involving the red carpet rule, creating departure sequences, and also partial taxi instructions. We then also had a look at conditional taxi clearances and how we can use them safely to lower our workload. We also had a look at when we want to transfer traffic to tower and the use of flight strips at larger events.